Alright class, welcome back after that short break. I believe you've been able to discuss among yourselves as to which of these A or B is the appropriate or the correct answer for this structure. Is it 5-ethyl 2,3? Let me put this 3-dimethyl heptane, or is it 3-ethyl 5,6-dimethyl heptane? Now you can see for both of them, they are all beginning with the alphabet E. Yeah, they're all beginning with the alphabet E, and then we said there are two methyl groups in which you're putting a di, but the alphabet for this dimethyl is not under D, but it is under M. Yeah. So that means that if you also had two ethyl groups, if you have two ethyl groups, it will be something like diethyl. Yeah, two ethyl groups. So it will not be under D, but it will be under E. So the alphabet it will be E. Are you seeing that? If you have two propyl groups, it will be dipropyl. It will not be under D, but under P. So that one we've already put E before M. Yeah. So that means that you do not put dimethyl first of all before ethyl, because that will be wrong. So you now put the ethyl first before M for the alphabet. I mean for the M for the methyl group M. Yeah. So M comes after E. Now this is number 5. This is number 3. Did you pick 3-ethyl 5,6-dimethyl? Now there is another rule which has been which exists, and that is to keep the number of the substituents low. Yeah, the total number. So in this case, you're going to see, and in this case, to know whether the total number of substituents is low, a rule, the best way of doing that is normally to see the total sum of the numbers before the substituents. Like this is 5, and this is 2, 3. So if you're going to add 2 plus 3 plus 5, that comes to around 10. Yeah, 5 plus 5, 5 plus 2, 7 plus 3, 10. Yeah, but if I'm going to add this 3 plus 5 plus 6, this comes to around 14. Yeah, this comes to 14. 11 plus 3, 14. So this one is going to give the total, the number of the substituents low. So this is preferred to that. But please remember, in an exam situation, even if you are to put this one as the name of the structure, like 3-ethyl 5,6-dimethyl heptane, you're not going to get all wrong, but there will be some marks for getting the parent chain and also for the functional group. Even if you don't get the exact numbering, at least there will be some marks. If, for example, that one was probably 2 marks, maybe you may get 1 mark for the parent chain and for the substituents correct. Yeah. But in this case, you are saying the correct name is 5-ethyl 2,3-dimethyl heptane. Okay. I believe you got that one. I think you discussed among yourselves, and I think you got the correct name. So what I'm going to do, I'm just going to get the same structure, but I'm going to add a functional group, and then let's see what you're going to do. What do I have? I still have, okay, let me get that. So that's what I have. That's what we had. And then what I'm going to do is that I want to add a second, just to extend the functional group a bit. In this case, it will be what? So let's see. It's the same structure, but what I've done is I've added an extra group here. So let's look at the longest coverage. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now, by lengthening like that one, it gives you a dilemma as to which direction you're going to take. Yeah? Because whichever way you look at it, it's all having the same number of carbon atoms. 1, 2, 3, 4, 5, 6, 7. The longest carbon chain, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right? That's an interesting structure. So let's try to see what name you are going to give to that. Now, now the rules indicate that you will have to maximize on the substituents. You're going to maximize on the substituents. So that means that even if the 1, 2, 3, 4, 5, 6, 7 or 1, 2, 3, 4, 5, 6, 7, the thing is this: if I was to number like 1, 2, 3, 4, 5, 6, and 7, that will have an isopropyl group. That's a 1, 2, 3. It's a 3 carbon atom, but it's an iso group. So it's a 3. It's an isopropyl, and then there's a methyl group or ethyl group on carbon number 5. So if I was to number like that one, so this will be 3. No, I'm going to do what? If I was to number like that one, I'm going to start numbering from the ethyl. So in this case, if I was to number like that, I'm going to get 5 ethyl, and then I get 3 isopropyl, and then because of the chain, or do I put the name here? So this will be heptane, yeah? Alright? If I was to number like that one, or if I was to number from the other side, like 1, 2, 3, so it means this will be what? 3 ethyl, then it will be 3, 1, 2, 3, 4, 5. 5 isopropyl. Okay, let me delete this one now. Now that we are dealing with the new structures. So this will be heptane, yeah? So the thing is, in this case, this one will give an E before the I, so that in this case you would try to say this is more preferred. But the thing is, as per the IUPAC rules, you've not maximized all the substituents, in which if, for example, I was to move like this one, then I'm going to have more substituents, yeah? But in this case, if you're to name like this one, you'd say that this would have been more preferred to this one, because the total number is the same, 5 plus 3 and 3 plus 5, yeah? It's just the same, yeah? Are you okay on that? But in this case, what you're trying to see is, we're still trying to come up with a name for this structure. You're going to see that if, for example, I was to stop there and probably I'll start numbering 1, 2, 3. The rest will be 4, 5, 6. Then I'm going to have a methyl group here, and I'm going to have an ethyl group there. So that will be more preferred than calling this one as an isopropyl group. So that will be a more preferred way of naming. So in that case, what am I going to get? I'm going to get, if I was to start numbering from here, I'm going to get a greater number of substituents, which is more appropriate when you'll be considering what? The IUPAC rules. So in this case, if I was to do that, I will see that I've got 2 carbon atom on a substitute on 2 carbon atom on carbon number 3, plus another one on carbon number 5, and then there's a methyl group on carbon number 2. Yeah. So what name are we going to give to this? It will be what? It will be 3, 5 diethyl, and then there will be what? 2 methyl. Are you seeing that? In this case, there is a 1, 2, 3. There is an ethyl group on this one, and there's another on carbon number 5. Or even if I was to move 5, 6, 7, this is still an ethyl group. Have you seen that? Now, what if I was to move the other direction? Yeah. Yeah. What if I was to probably start from here? 1, 2, 3, 4, 5, 6, and 7. As I mentioned, like that one, straight away you know that will not be correct, because that will give the ethyl group on carbon number 3. Okay, it will still be, okay, let me see. Okay, let me see. That will be 3, 5 diethyl. Then there will be what? 6. What I'm saying is this. If I was to start numbering from here, the ethyl group will be on carbon number 3, the other one will be on carbon number 5, and then the methyl group will be on carbon number 6. Have you seen that? So this will be more preferred than that, yeah? Is there any other possibility? I think that's those are the possibilities. So I'm just trying to see. So what? I'm just trying to see. Have you chosen on the right one? So this will be what? It will be 3,5 diethyl, 2 methyl heptane. So what I want to do is to so this will not be the correct one. So it means that so let's see. In this case, that is not the correct one. That's the correct one. That is no, sorry. That's not the correct one. That is the correct one, and that's so. Out of those possibilities, there's only one answer. But once again, if you are to get the parent chain correctly, then I think the examiners will just find a way of seeing that what you have correctly, and then you're going to get, and then you'll be given some marks appropriately. Now, in this structure, I want to add an extra group here. Okay, let's get what we had here. Okay, that's what I have. What if I was to add another group there? I was to do what? It's just the same structure, but I'm just trying to add, and then we try to see how we can formulate some rules, or we can come up with appropriate rules to name what you have. All right? So, excuse me. So in this case, we said, if I to start from here, it will keep the substituent the lowest number. So in this case, we are saying the best way is to start numbering from here. Probably if it was to start numbering 1, 2, 3, then we said this will call this group as isopropyl group, and that is not appropriate. But if I was to number from here, probably from here, or if I was to number from here or here, so that I call this probably come on number 1 and number 2 and number 3, number 4, number 5, either number 6 and number 7, something like that. Then I will see that I'm going to get a substituent here and another substituent here as opposed to an isopropyl group. Right? So you see as to why we are not beginning from here, because that will give a more bulky substituent as opposed to many smaller substituents. So in this case, we're either going to put a number 1 here or number 1 here. So the longest carbon chain is the one which I'm showing, like that. I can either move like this one because the same number of carbon atoms, yeah? So in this case, I will see that that I've got a methyl group on carbon number 2. I've got a excuse me, a methyl group on carbon number 3, and then I've got an ethyl group on carbon number 3 and an ethyl group on carbon number 3. So in this case, there will be two groups containing a di. There will be a di for the two methyl groups, and there will be a di for the three ethyl groups. Yeah. So in this case, before you come up with the name, you are going to say maybe I'll say ethyl group. It is on carbon number 3 and 5. Methyl is on carbon number 2 and 3. Have you seen that? Methyl, yeah. On carbon number 2 and carbon number 3, ethyl group is on carbon number 3 and carbon number 5. Now we are going to begin with the ethyl for the E before the M. So there will be a di because I've got two ethyl groups and I've got two methyl groups. Yeah. So in this case, I will get a what? This will make it a 3,5 diethyl. You understand? Because it's on carbon number 3 and carbon number 5. And because I've got methyl group on carbon number 2 and 3, so this will be 2,3 dimethyl. Are you seeing how we are coming up with those two names? Ethyl group on carbon number 3 and 5, it becomes 3,5 diethyl. Methyl is on carbon number 2 and 3, so it becomes this becomes 2,3 dimethyl. And then the total chain has got 7 carbon atoms, so the name will be heptane. Yeah, just the same thing. Yeah, it will be heptane. So let us see what name we are going to give to this. Let's see the name. So want to put the E for the ethyl, even though it's starting with a di, going to put E before M. So this name is going to come first, and then the other one is going to come next. And then we'll come up with the name. So I'm going to put 3,5 diethyl, and then I put a dash for the next substituent. So it will be 2,3 dimethyl, and then I put a dash, and then the parent chain is heptane. Alright? Have you seen that? 3,5. I don't know why this 5 is not looking correctly. Yeah, like that, sorry. Okay. 3,5 diethyl, 2,3 dimethyl heptane. Can you see how the name is? It may look complicated, but I think you've seen the rules are so simple. Yeah? Yeah? Have you seen that? Very simple. Yeah? So I want to make it. I want to see how I can come up with another one slightly more complicated. Still based on that structure. I want to see how I can. I want to delete this part. The good thing about this is that this is a video, and it is this is a video. So in case you do not understand the concept, you can just press pause and probably go back to see that explanation. This is much better than in an online class, whereby if you missed a point, then unless if you find a way of recording it, there is no way of going back. But in this one, this is a YouTube video, so you can be able to pause, you can be able to go back, and life will be easier. Right? So let me just try to put another structure. Yeah? Let me put another structure, and then we can proceed from there. Okay, I'm just trying to draw that. I put a group there, and then let me delete those ones, and then I'm just trying to draw and then I put that one. All right. Can you see well on the board? I hope it's in here. So I want to see. Okay. Perhaps if let me just try to put it slightly down. I don't know why it looks a bit not. Let me try to get it correctly. Okay, good. That's what we have. Yeah, now that one is more clear on the board. Yeah. I'm just trying to see. So let us see. Which is the longest carbon chain? Maybe if I look at here, 1, 2, 3, 4, 5, 6, 7, 8. That is 8, even if it's here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is longer than that one. If I was to move like 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. So that is not the longest chain. So the longest carbon chain is probably 1, 2, 3, 4, 5, 6, 7, 8, 9. Or maybe 1, 2, 3, 4, 5, 6, 7, 8, 9. Can you see it like that? But according to the rules, we say that as much as this one is giving 1, 2, 3, 4, 5, 6, 7, 8, 9, this is giving a bulky group containing 1, 2, 3, 4. It's like a what? Tertiary butyl substituent. But what you want to see is that the best thing is if I was to move, for example, like 1, 2, 3, 4, 5, 6, 7, 8, 9, that will give 2 substituents plus an ethyl, which is better than moving like this one and then say you've got one bulky substituent. So according to those rules, is that you need to start numbering from here, because that will give as many substituents as possible. So according to that, and if I was to move like this one, I'll give the numbering those many substituents the lower number than moving from here. So straight away, you know, I'll start numbering from here. Either here, maybe I start from 1, 2, 3, 4, 5, 6, and we said we do not move here because we come to 8. So this 7, 8, and then 9. Have you seen that? Now, if I do like that one, because the longest carbon chain is that one, I'll have no alternative to this one, because this does not give the longest carbon chain. So I will eventually have a what? An isopropyl group. I cannot make it to be many smaller substituents. Yeah. So this will still be isopropyl group. So I've got as many substituents as possible. So let us look at the substituents and then look at and then let's come up with a name. There is a methyl group on carbon number 2 and another methyl group on carbon number 2, and then there is no other methyl group. So there is methyl. It's on carbon number 2 and another on and another on carbon number 2. Yeah, on carbon number 2 and 2. So you don't say 2 dimethyl, but if they are 2 on the same, you usually say 2, 2 dimethyl, for example. And then there is an ethyl group, ethyl on carbon number 3, and then there is an isopropyl on carbon number 6. Please note there's a difference between the isopropyl and then that is called a methyl group. That's called a propyl group. 1, 2, 3. That is a propyl group. 1, 2, 3. But now I've moved that methyl. I put it here. So it is an isomer of the propyl group. This is called isopropyl. It's called what? Isopropyl. Isopropyl is different from the propyl. And something which I said is that under isopropyl, the name starts from I as opposed to the propyl. But if it's just the normal propyl, the name starts from P. You need to know a difference of that one. Isopropyl, the alphabet begins at I, as opposed to a propyl, the name begins at P. Have you seen that? Okay, so this is what we have here, And then the parent chain has got 9 carbon atoms, so the name will end with nonene. Will end with nonene. So let us see how we can name it. Alphabetically, there is the E coming first. E. Then which other one? Before we come to M, there is the I, yeah? As I mentioned, it's not under P, but it's under I. Isopropyl is one word to distinguish it from the normal propyl, yeah? So this will be, I will put a number 3, ethyl, and then I put dash 6, isopropyl, and then I put 2,2 dimethyl, and then I put the one nonene. Have you seen that? So that will be the name of the structure: 3 ethyl, 6 isopropyl, 2,2 dimethyl nonene. Okay. So I want to see whether I can add, I want to make a slightly more complicated structure. I want to see whether I can add another more complicated structure, but still related to this. What I want to do is probably at this position. Okay, so I'm through with this one. So let me just try to add another structure. Probably I put a group there, and then probably I put another group there. All right. All right. I'm just trying to make it a little bit more complex, because you are just trying to come up with some rules. So what I'm saying here is that if I do like that one, once again, if I was to begin from either direction, maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe 1, 2, 3, 4, 5, 6, 7, 8, 9. So whichever way I look at 1, 2, 3, 4, 5, 6, 7, 8. So that's not the parent chain. So the longest carbon chain, it will be the way I've drawn, and then from here 6, 7, whichever way I can do it, 8 and 9. That will be the longest carbon chain. So there is a methyl group on carbon number 2 and number 2. There is another methyl group on carbon number 6. 2, there's another one on carbon number 2, and then another one on carbon number 3. Then there is an ethyl group on carbon number 3 and another one on carbon number 7. And then the same isopropyl group is on carbon number on carbon number 6. So let us put those substituents down. So methyl is on carbon number 2 and another one on carbon number 2. So ethyl is on carbon, I'm just putting that one, is on carbon number 3 and 7. And then there is an isopropyl, yeah? It's on carbon number 6, and there is no other one. So this will mean this will be 2,2 dimethyl, yeah? Have you seen that one? That will give that. So this will be 3,7 diethyl. And then this will still be, this will be 6 isopropyl. Can you see that? So this is how the names are going to be. Now because the longest carbon chain is 9 carbon atoms, you're going to get the name nonene. Yeah. So let us see how we can come up with the name containing the parent chain will be nonene, and it's going to contain dimethyl, diethyl, and isopropyl. So this diethyl, it will be alphabet. Let me put it in. Perhaps I show it. So it will be alphabet E, first one. Then which other one? The next one, it will be alphabet I, for the isopropyl, then M, that will be the last one. So the name for this one, it will be what? It will be 3,7 diethyl, then it will be 6 isopropyl, then 2,2 dimethyl, then nonene. It is becoming long on the board, yeah, but you can make sense. 3,7 diethyl. Can you see? Then dash 6,6 isopropyl, then dash 2,2. Oh, sorry. I've forgotten. And I think I'll have to redo it again. I've forgotten there's another methyl group on carbon number 7. So sorry. So this will not be. So this 2,2,6. So this is triethyl. Oh, triethyl. Yeah. Sorry. 2,2,6. So oh dear. I'm sorry for that one. 2. So there will be 2, 2 and 6. So it will be 2,2,6. Oh dear. So this will be 2,2,6. That will be good. Good. So 2,2,6, and then I'll have trimethyl, and then nonene. Sorry for that. Yeah. So let's see, 3,7. I think I've taken account of all the substituents. Ethyl groups, those two. Let me see. Let me sample them. Ethyl groups. There are those two. Isopropyl group, and then there is that methyl group, another methyl group, and another methyl group. Those three. Yeah, I've taken care of all the substituents. Have you seen that? Those are all the substituents. So the name will be 3,7 diethyl. E comes first, then I, then even though it's trimethyl, it's still under M. All right? E before I, before M. Yeah, that alphabet. So 3,7 diethyl, 6 isopropyl, 2,2,6. So that you just say the 3 methyl groups, 2 of them are on carbon number 2 and 1 is on carbon number 6. That's what it means, yeah? Okay? So I want to get on to the same structure which I have here, and then what I want to do is to perhaps let me put the structure here. This is what I had. That is what I have, and then what I want to do, I want to change this isopropyl group into a normal propyl group. Have you seen what I've done? I've changed into a normal propyl group. Yeah, 1, 2, 3. So the longest carbon chain is still 1, 2, 3, 4, 5, 6, 7, 8, 9. The rest will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, so the thing is, this one is going to give what? More substituents. So in this case, I will not move like this one. I will move like that. That will give let me see, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That will give more substituents. So the only thing that will change. Okay, let me see. 6. Let me see. rather than in this case, the only difference I've made, okay, let me see what I have. I've got what? I've got 2,2,6 tri. I've got methyl groups. Can you see well? 2,2,6 trimethyl. Then the ethyl groups are still on carbon number what? 3, and then also number 7, 3,7 diethyl, and then I've got what? 6. I've got 6 propyl, yeah. I've got propyl on carbon number 6. So in this case, what am I going to have now? Now the way I'm going to get the name, I'm going to see that E is going to come before what? M is going to come before P. Have you seen that? So the name for, if this is structure A and this is structure B, so the name for, so this was A, so the one for the B, so the name will, the other substituents will still be the same. It will be 3,7 diethyl. And then now, because I do not have isopropyl, I've got a propyl. The other substituent, the one which is starting with the M, is going to come now before the propyl. So I'm going to have 2,2,6 trimethyl, and then I'm going to have what? 6 propyl nonane. Have you seen that? Have you seen that? So 3,7, the rest will not change, but now because I've got I've now replaced my isopropyl with a propyl. With a normal propyl, you don't put N-propyl, you just put the normal propyl, you just put propyl. But P comes after N. Initially it was isopropyl is one word coming under I, and it is I comes before M. In this case, your M comes before P. Have you seen now how the alphabet has changed? So this will be 3,7 diethyl, 2,2,6 trimethyl, 6 propyl nonane. Yeah, for the two structures. Yeah. Okay, so I think that's the much I will talk about the the naming of alkanes with substituents. The name of the alkanes with the substituents. So the rest of the thing about alkanes, about their properties, your physical properties, and their uses. Alkanes do not have functional groups, as you're going to see for alkenes, alkynes, and the rest. So they are mostly used as fuels, and we look at more about their fuel properties under the topic of fuels. So, but as for now, I think this thing about the naming of hydrocarbons, and particularly alkanes, it was a very, very important topic, and I had to really spend a lot of time clarifying about the naming of alkanes as per the IUPAC rules. I believe the rest of the notes about alkanes are going to be simple, and there is the reference book of which you can get more exercises towards the end. Under hydrocarbons, I think you can look under the topic of alkanes. You can look. There's some exercises at the end. There are some structures which are given there. In the exercises, you'll be able to name those structures. And if there are issues, then when you'll be looking at, when you'll be through with the carboxylic acids, we'll spare some time to have some online tutorial session in which you'll be able to put forward any questions or things which require clarification in the class. But as for now, I think with all of these different structures which I've put on the board, some complicated like this one which I've shown here, they're going to give you some, I think they've given you some experience as to how to name alkanes with substituents. Yeah, I believe things are now clear. You'll be able to name any structure of alkane with a substituent. And now I think in coming to an end, I believe it will be easy to convert this bond line structure to the two-dimensional Lewis structure, in which this will be CH3, CH2, CH, no, this is carbon because there are no hydrogens, carbon with no hydrogen, so these are CH3, 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 CH, CH2, CH2. This is carbon because there is no hydrogen, it's a tertiary carbon. These are CH3, CH2, CH2, CH3, CH, CH2, CH3, CH2, and CH3. Can you see that? So you'll be able to draw with the carbon with the various hydrogens, yeah? I believe you've really enjoyed this section of the note. It may look a bit complicated, but it's not complicated. The rules are simple, they are quite straightforward, yeah? So I'm going to stop there, and I think you look at the rest of the notes on alkanes, particularly the ones containing the ring. It just means if you have okay, if I can delete this one, this to give an example. If you've got something like a CH2, maybe I've got a CH2, I've got another CH2, something like that. So this is equivalent to something like that, yeah? There's a CH2, 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 CH2. So this will be a butane because it has 1, 2, 3, 4. And then I'm just going to add cyclo at the beginning. So this will be called cyclobutane. And if you've got a cyclobutane, and then it has something like a methyl group. So this will be methyl cyclobutane. And once again, if you have other substituents, then the numbering will be the same. It will be the same. For example, if I have something like 5 carbon atoms, I've got that, and then I've got a second one. So there is a methyl group and there's an ethyl group. So you need to give the numbering to the smallest, to the lowest alphabet. So I'm going to start numbering from here, and then I move like this one, 2, 3, 4, 5. So this will be 1 ethyl, and then there will be 2 methyl, then it will be cyclo what? Pentane. Yeah? Have you seen that? Very simple. So with that one, we'll be able to look at how to even name the alkanes which form a ring. You simply put a cyclo, otherwise the rest of the rules would be the same as the one for the straight chain. Now the ones which do not have a ring, they're called cyclic. It means they are straight chain, and these ones which have got a ring, they are called cyclic alkanes. Yeah, these are acyclic alkanes. The ones the one which I've drawn here, these are acyclic. It means they do not have a ring, and these ones which have got a ring, they are called cyclic alkanes. So with that, you'll be able to go through up to lecture 6 of the notes. Yeah, thank you very much, and we'll be able to now proceed to the next topic, that is alkenes, the next functional group, which contains the carbon-carbon double bond. Thank you very much. We'll see you shortly. Okay, so you'll be able to, you can see well what we have in the board. Thank you very much.